Here's what today is. Computing the volume of spheres. We'll get to that in just a second. Who is supremely confident in their answer to this one right here? And keep in mind, we've talked the last couple weeks about sometimes we like numeric examples. We've done numeric examples. This one is kind of in general. What would you do with this shape? D, tell us what you got.
I put 1/3 then pi times r squared times h1 plus, and then another set of parentheses pi times r squared.
Okay, hold on 1 second. 1/3 then parentheses pi r squared. Tell me what comes next.
Times h1.
H1, okay.
And then plus, and then another set of parentheses pi times r squared times h2 equals q.
Okay. All right, and that would be, and we don't have units here, but this would be cubic units. Yeah.
I think I did it better.
Tell us what you did.
Okay, so I did pi r squared times 2 parentheses.
You mean like that?
No, like another parenthesis.
Another one?
Yes.
Like this?
Yes, and then 1/3 h or n1. I can't tell what that is.
H1
Okay, and
Parentheses.
then another parenthesis, and then plus h2.
in parentheses H2. Okay.
What the heck?
Yeah.
Does
I
have
did
to
it
be
simpler
like that?
where I didn't use the double parenthesis and I just did h2 plus 1.
So you did pi r squared and then you did
1/3
1/3 H1 plus
plus-
H2.
Yes, because order
Okay.
of operations.
Okay, hold on 1 second. Okay, these are all correct. These are all fine. Let's say this is 1, 2, and 3. Let's make sure everybody understands number 1. Okay, this is the volume of a cone, 1/3 pi r squared h. So 1/3 pi r squared, so this is r. So we've got r squared times h1, because that's the height of the cone. And then this one is the cylinder. So we've got the cone right here, and then we've got the cylinder right here. So that's just going to be pi r squared h. So pi r squared, we're using the same radius for both the cylinder and the cone. And then height here is just h2. That's the way they're denoting it. So everybody good with that one?
Yeah.
Raise your hand if you got something like that. Okay, perfect. Okay, can somebody raise their hand and tell us what did Luke do right here to go from V1, the first formula, to the second formula? Yeah.
He almost pulled out the GCF kind of.
Oh, very good. Right terminology and everything. Pulled out the GCF. We have a pi and an r squared in each one of them. It's the same radius for both of those. So we have that same factor in each, so we pull that out. Are the double parentheses okay? Yep. Is this a more efficient use right here?
Yeah.
Okay.
Yeah.
Which one is the cleanest? 1, 2, or 3?
3.
Probably 3. But it's tough to get to 3 without having at least this idea that you most everybody got for the
So that's the
V1.
idea.
Everybody got it?
Equation.
Okay. All right. So here's the formula for the volume of a sphere. It's 4/3 pi r and then something. Do not say anything out loud. We're talking about a volume. We got a fraction 4/3, so we've got this factor sitting out front. Pi, no surprise, we've got a circle in there somewhere. R raised to a power. If we're going to have volume, volume is measured in, think about it for a second, what would have to go on there? Anna, what do you think? Raised to the power of 3, or we're going to say cubed. So if somebody says, what's the formula for the volume of a sphere? You're going to say 4/3 pi r cubed. Okay? So we're going to watch a quick little video. It's a demonstration of how this works. It's about, I think it's 2.5, 3 minutes long.
Why cube? Why not
I'm gonna
square?
fall asleep during this.
Okay, so I'm going to stop that, and then I'm going to ask the same question I usually ask. Proof or demonstration?
Definitely both. Demonstration at the start.
Okay, the only, so I would say really good demonstration with kind of a little bit of proof. But what that depends on is there was an assumption at the very beginning. In order to say that those two cones equal the sphere, you relied on a demonstration of pouring the water in there, right? Okay, and that's definitely a demonstration. That's not a proof. Okay, because just because it works in that case doesn't mean it works in all cases. If you want to see an actual proof of this, they're pretty complicated, and a lot of times they rely on calculus. So here's the bottom line. We need to know this formula right here, and then we plug things in. So if this was a test, we'd want to show work to show that we know what we're doing. So we'd want to have the 4/3 pi, and then we have the r. So r in this particular case is 2. We're going to cube that. So we end up with, let's see, that's going to be 8. Nothing cross cancels. So we're going to end up with 32 pi
Yeah.
over 3. And that would be in feet cubed, right? You could get a decimal approximation for that. If you were listening, he also said some people remember it this way: 4 pi r cubed, and then we divide that by 3. So it doesn't make any difference if you want to think of the 4/3 sitting out front.
Oh, I like
That's
that.
totally okay. If you want to think of 4 pi r cubed on the top and then divide the answer by 3, that's totally fine too. The coefficient thing is kind of nice because then we get used to just having it sit there. Would you do B, please?
Yeah.
Oh,
Who do I need to call on for an answer on this?
Maybe sign.
Maybe. He's smiling.
he knows. He's learned from his mistakes. He's taking it.
Luke, what do we need to be careful with?
Decimal approximation.
That's a diameter right there.
It is. So what do we need to be careful with?
We need to make sure we use the radius.
And what is the radius?
4.
Okay, so we're going to have V equals 4/3 pi, and then the radius is 4, and we're going to cube that. So that's going to be 64 times 4. So 256 pi over 3, and that would be inches cubed.
Yep.
Okay, now, you may find these answers on an assignment, on a test, on a standardized test, on a computer test, or something like that. You might also find a decimal approximation. So would you throw both of those in, approximate the decimal, and then just check with your neighbor, make sure you got it right?
What'd you get for the last one?
68.08.
That's fine.
Yeah.
Wait, so what would we do?
What'd you get for this one?
Uh,
Oh, yeah, sure.
yeah, that.
Because
I did the same one. I typed it later too.
Anyway.
33.5.
33.51. Is that rounded the right way?
68.08.
Yes.
Don't just screw around.
I know how to round.
Wilson, what'd you get on this one?
On the second one. 268.08.
268.08. No, you didn't.
You gotta
round.
make
Oh,
Okay.
yeah, I forgot to keep-
We in good shape with the decimals? Okay. All right, listen up. Hopefully you checked, rounded right, and all that sort of stuff. I'm going to ask Lydia. Lydia, basketball has a radius of 8.7 inches. Find the volume. Tell me what to write down.
volume equals 4/3 pi parentheses 8.7 cubed.
Perfect. And Samara, what are the units going to be in when we get done?
Inches cubed.
Okay. We'll get a decimal for that. I'll trust that you can type that in. Next one, hemisphere. Find the volume of a hemisphere if the diameter is 10 feet. So, Sai, what's the first thing we need to be careful of on this one? Very good. What's the radius here? 5 feet. Okay. Now, would you write down the formula you're going to use for a hemisphere? Somebody want to tell us what a hemisphere is? D, thanks for the hand.
It's like a semicircle.
It's a semi-sphere. A hemisphere is what fraction of a sphere? It's half a sphere. So can you keep going? Tell us what formula we're going to use.
The formula you use is you put 4/3 pi, and then you in parentheses 5 to the power of 3.
Mm-hmm.
Then you would divide it all by 2.
Then you would divide it all by 2, or we could do,
2/3.
yeah, we could do a 1/2 in front there, and we could simplify this by canceling that off. So the formula for the volume of a hemisphere would be not 4/3 pi r cubed, but 2/3 pi r cubed. Okay?
That's smaller.
It is smaller. It's exactly half the size. Thank you very much. Okay, and you can get the decimal for that? Okay. And one more question, then I'll hand out the assignment. Colson. Oh, I should write a cube. Thanks. Colson, what's different about problem C?
We have the volume, but not the radius.
Very good. So can you tell us what to write down?
24 pi equals 4/3 pi r cubed.
R cubed. Great. Okay. Let's see. Kalea, I want to get rid of this fraction in front of the variable. How do I get rid of a fraction in front of the variable? Multiply by its reciprocal. Great. We're going to multiply by the reciprocal. So we're going to multiply by 3/4 on both sides. And then there's something else that I can get rid of. Crew, what else can I get rid of?
The pi.
The pi. So if I wanted to, I could flip that whole thing, consider that 4 pi thirds as a fraction. So we're going to divide by pi, and of course that's going to cancel. Okay? So this is going to cancel. That's going to be a 6. Cross cancel the 4 and the 20 or the 24. So that's going to be 3 times 6. We're going to get 18, and 18 equals r cubed. And wait just a second. How do I undo cubing?
I like this one.
How do we undo cubing? Keely, take the
Mess
cube
me.
root. Where's the cube root button on your calculator?
Oh,
In math.
It is. In order
It's
to
in
find
math.
the cube root button, you're going to find that in math. So we're going to hit math. It's number 4. It even makes it look nice. So cube root of 18.
2.62074139.
Okay.
Just kidding. It's just
Okay.
2.62 centimeters.
Does anybody know a different way to calculate a cube root?
Taking it to the power 1/3.
Ooh, wow. 18 raised to the, and I'm going to put this in parentheses, 1 divided by 3. The 1/3 power is also a root. Okay?
Wait, so it's one
D
half.
is on fire.
It's 1/2.
1/2 is a square root. Very good.
It's 1/4.
Whoops.
Screw, you know